Welcome back. This is All This Math. I'm Professor Parker. And please make sure that you're subscribed to the channel. Make sure you hit the like button. Also, drop a comment down below if you got any questions or comments or anything you're wondering about when I get into my explanation of how to do this problem behind me. And also share this video with somebody. All right, so what are we doing here? Let's read the instructions. It says to find the slope of the line perpendicular, this upside down capital T. Whenever you see an upside down capital T, that means perpendicular. Now, what does perpendicular mean? You probably see that a lot or hear that in geometry, but you could also see it in Algebra 1. Perpendicular is when the lines look just like these two lines look. This vertical line and this horizontal line, they form a 90-degree angle with each other, right? Not to be confused with parallel lines. Parallel lines go in the same direction and they will never intersect each other. All right. And every pair of corresponding points on two parallel lines are equidistant, meaning this point on this line is a certain distance away from this point on another line. Way up the line, it's going to be the same relationship between corresponding points, you know? So anyway, this upside down capital T means perpendicular. All right. So find the slope of the line perpendicular to this line. All right. So we got this line right here. And we want to find the slope of a line that's perpendicular to it. Now, why would you want to do that? We would want to do this because we might need to find that actual line, right? We might need to find the equation that represents the line that is perpendicular to this line for a lot of reasons, right? It could be an application, could be some type of business application, it could be a science application, because that's what we use algebra for, right? For business and science and a lot of other things too. All right. Slope. Okay. So first thing we want to do is we want to figure out the slope of this line. Now, I usually do this in two different ways. So I'm going to do this in two different ways on this problem. All right, let's get into it. So first, using standard form, what we call standard form. Now, what is standard form? Standard form is AX plus BY equals C. That's the form that this equation is already in. It's already in standard form, right? Meaning, this equation, the way it's written, it looks like this, except instead of an A, you got a -6. Instead of a B, that's supposed to be a capital B. Forgive me. That's a positive. You got a +2. Instead of a letter C, you got a 2. So this equation is written in what we call standard form. All right. Now, another way that you'll typically see these equations written is in what we call slope intercept. I'm going to just write INT for intercept, like intercept. You know, right? Slope intercept form, right? That is written as y equals mx plus b. Now, this b, this lowercase b, is not the same thing as this capital B. I'll repeat, this lowercase b is not the same thing as this capital B. All right, now, we can use each of these forms to figure out what the slope of this line is. That's our first step. We got to figure out what the slope of this line is. Once we figure out the slope of this line, then we do something to that slope, do a couple things to that slope to figure out the slope of a line that's perpendicular to it. All right, and then we get to that in a minute. But our first step is to figure out the slope of this line. And we can use either form to figure it out. Now, I'm going to do it both ways. I'm going to show you both ways, and then you could choose which way you like better. All right, but it's good to know how to do things in more than one way. So using standard form, there is a formula, right? The formula is M equals -A over B. That's the formula we use, right? What does it look like? It looks like this. M is equal to capital A over B. Now, where does A come from? A is the coefficient of X, right? B is the coefficient of Y. So we replace the A with this -6. But be careful. This is a mistake a lot of people make. This formula already got a negative sign in it. It already got a negative sign in the numerator. So what some students do, it's the mistake they make. They say, oh, well, this number is negative, but since the formula already has a negative sign, I only need to write one negative sign. No, you got to write both of them. Because remember, you're replacing the A with -6. You're not replacing the negative sign. The negative sign is going to be there regardless. So remember that. Write that down in your notes. The negative sign is going to be there regardless. The negative sign is going to be there regardless. So what you got to do is you got to write negative, and then it's good to put it in parentheses to separate or show the separation between the negative signs, right? That's why we use parentheses sometimes. We got negative, whatever A is. A is -6, so we got a -6. It's a double negative. It's a double negative. That happens sometimes in algebra. And then for b, we replace that with positive 2, right? So now double negative, negative 6 becomes positive 6, because that's like saying -1 times -6. And whenever you multiply negative times a negative, you get a positive product. So we got, we got positive 6 divided by 2. That's 3. So the slope of this line is 3, right? Now, a lot of teachers, may not want you to use that method. So that's why I also advocate for you knowing how to convert this into slope-intercept form. And once you convert it into slope-intercept form, you can just look at it and tell what the slope is. The way you convert it into slope-intercept form is like this. You solve for y. You solve for y. Treat this like an equation, solve for y. Now, when I say solve for y, we're not going to come up with a single number that y is equal to. We're going to come up with an expression that y is equal to. So it's not going to say, at least not in this case, it's not going to say y equals 2, or y equals 1, or y equals 5, or y equals 8, or y equals -13. That's not going to happen. You're going to end up with an expression. Y equals a number times x plus another number or minus another number, right? That's what's going to happen. So that's still considered solving for y. All right, so let's get into it. I'm going to rewrite the equation. -6 plus 2y equals 2. Now I'm trying to solve for y. So first thing I'm going to get rid of is this -6x. That -6x has got to go from the left side of the equation. So I'm going to do the opposite operation. The opposite of a negative is a positive. So I'm going to add 6x on the left, and I'm going to add 6x on the right. So I'm going to do plus 6x on the left, plus 6x on the right. -6x plus 6x cancels out. That becomes 0. I draw my horizontal line to try to keep things organized. Then I bring down the 2y, bring down the equal sign. Now, 2 plus 6x does not equal 8x. I don't want to see nobody writing that down. It does not equal 8x. These are not like terms. You can only add or subtract like terms. What's a like term? All constants or numbers are like terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Decimals, fractions, positive, negative. All numbers are like terms. All variables with the same exponent are like terms. Variables and plain numbers, or variables and constants, are not like terms. That's a 2. That's a constant. That's not like 6x. That's a 2. That's an x term. That's a number term. That's an x term. You can't add them together. You can't subtract them. But you can multiply or divide them, because we got different rules for multiplication and division than we got for addition and subtraction. You got to understand it. Just like in your house, your parents got a certain set of rules under their roof, right? You might go to somebody else's house, one of your friends' house, their parents might be a little more lax. So you might like going over there because you don't got to abide to certain rules, right? But when you come home, you got to shift gears and get back into, oh, I'm back home now, so I can't do what I've been doing all weekend, right? So addition and subtraction have their own rules. Multiplication and division have their own rules. Remember that. So we can't add 2 and 6x. We just write them next to each other. So we just write 2 plus 6x, right? So 2y equals 2 plus 6x. All right, now I want to solve for y, so I got to get rid of this 2. How do I get rid of the 2? I do the opposite operation. 2y means 2 times y. 2 times y. That operation is multiplication. So you got to do the opposite of multiplication. What is the opposite of multiplication? Division. So we're going to divide everything by 2. Some people like to write one fraction bar and just write the 2 one time. You could do that too. It's going to give you the same result. It's going to give you the same result. Like I said, some people like to write one fraction bar. Matter of fact, I recorded another video where I did it that way. I wrote one fraction bar and I wrote the 2 one time, but it's going to give you the same result, because either way, you still got to divide 2 by 2 and 6x by 2. So 2 divided by 2 is 1, which gives us 1y. 1y, algebra language, is the same thing as just regular y, right? 2 divided by 2 is 1. 6 divided by 2 is 3. Remember what I told you. We can't add and subtract 2 and 6x, but we can divide 6x by 2. We can do that, right? Divide 6x up into 2 equal parts. That's going to be plus 3x. Now, I want this to look like this, right? So what I'm going to do, I'm going to switch the x term with the constant. I'm going to switch the x term with the constant just to make it look like this, because that's how I want it to look. So I got y equals 3x plus 1. Now, slope-intercept form, whatever the coefficient of x is, that's the slope. So 3 is the slope. And wasn't the 3 the slope over here? So like I said, if you got the option and your equation is in standard form, go ahead and do this. If you have the option, if your teacher wants you to solve for y, and put it in slope-intercept form, then follow their instructions and do that. But you notice we get the same answer. That's a beautiful thing. Now, that's the slope of this line. Now we're trying to find the slope of the line that's perpendicular to it. There are two things you got to do to the slope to get the slope of a line that's perpendicular to it. You got to do two things, not necessarily in this order. The order don't matter. But you got to give it the opposite sign, and you got to take the reciprocal. Give it the opposite sign and take the reciprocal. You could take the reciprocal first and then give it the opposite sign. You could give it the opposite sign, then take the reciprocal. It don't matter. All right, so this 3, right? So I'm going to write M with a little perpendicular symbol right there, right? First I'm going to say, well, what's the opposite of positive 3? The opposite of positive 3 is negative 3. So it's going to be negative 3. I'm going to write that. But then I got to take the reciprocal of that. What's the reciprocal of negative 3? Well, negative 3 is the same thing as negative 3 over 1. When you take the reciprocal of any number, when it's written as a fraction, you basically switch places between the numerator and denominator. The denominator goes up top, the denominator goes up top, the numerator goes down bottom. So this negative 3 is going to go down bottom. This 1 is going to go up top. So now I got 1 over negative 3. That's the slope of the line that's perpendicular. So let's go back. What were the steps? First, you got to figure out the slope of the original line. The original line. This equation represents the original line. An equation is like a name. The line is a graph, right? So just like all of us, there's pictures of us, but we also got names. We got names that are written down, but there's also pictures of us, right? This is the name for the line. The way the line looks is a graph form of it, a straight line somewhere on an XY coordinate plane. First, you find the slope of this line, and then we found this 3 and 3. Then to find the slope of the line that's perpendicular, you got to do two things to that slope. You got to make it negative, or actually, I'm not even going to say that. You got to give it the opposite sign, because if it was already negative, it's going to become positive. But since this was already positive, it's going to become negative. So two things you got to do. You got to make it negative and then take the reciprocal. Or if you want to, you can take the reciprocal first, then make it the opposite sign. It doesn't make a difference, right? You still going to end up with the same answer, negative 1/3. Now, also, let me say this real quick, too. This says 1 over negative 3, but that's also equivalent to saying just negative 1/3. Because in a fraction, if one of the numbers, numerator or denominator, is negative, that makes the whole fraction negative. That's what it does. It makes the whole fraction negative. So it wouldn't make a difference, even if it was negative 1 over positive 3. That still equals negative 1/3. See how the negative sign is written adjacent to the fraction bar, right? So just as long as you know that too, because that's a very important concept in terms of dealing with negative fractions. All right. So go get some practice with this, and I'll see y'all in the next video. Peace.